I recently made a video about the search for the Higgs boson particle, and on that video there were a lot of comments that basically just said, what is this thing? You'll often hear people say that the Higgs gives things mass, and that is theoretically, technically true. But why does there have to be something that gives other things mass? You'll also hear it called the God particle. I kind of dislike this personally. But without understanding quantum mechanics and field theory and the Standard Model, it's hard to get any deeper than that, and understanding those things is really complicated. So it's hard to explain, but you asked for it, so here it is. So you know about forces. Electromagnetism is the most common force in our daily lives. We see it when we stick a magnet to the refrigerator. There's a force there. It's also the thing that's keeping me from falling through my chair right now. Electrons pushing on electrons so that atoms don't pass through each other. But there are also other forces. There's gravity, and there's the strong and weak nuclear forces. The world had previously thought that these forces were continuously radiating fields that came out from the source of the force. But quantum mechanics doesn't allow for continuousness in that way, and so what we figured out, what scientists have realized, is that it's not a field in the traditional way of understanding a field. It's actually a distribution of particles. And the strength of any given field is actually the density of those particles at that point. So for example, a magnet, which we know has a force around it, has a high density of these invisible particles called virtual particles snapping in and out of existence around it. The density of the particles is much higher near the magnet and drops off exponentially as you move away. These particles are very weird and wibbly and difficult to conceive of, but because they're constantly snapping in and out of existence, they can't exist in the way that normal matter does without violating the law of conservation of energy, which says that things can't just start existing. So they aren't matter. But these virtual particles are actual particles. The trick has been to coax them into existence so that we can study them. Because mass and energy are equivalent, given the right circumstances, we can dump enough energy into a system to actually make these virtual particles real particles. We do this using particle accelerators, and we've done it before. This is how we know that these force carrier particles actually exist. Physicists figured out that they probably should exist, and then they created the circumstances necessary, dumped a bunch of energy in, and then they did exist. And we said, there it is! So those are the virtual particles that create forces like electromagnetism that, two magnets won't pull each other apart. But mass doesn't feel like a force in that way. Mass is just something that you have all the time. Why does there need to be something to explain that? The idea is that the universe is permeated with an even distribution of a force carrier particle for mass. And that is called the Higgs field, or the Higgs particle. So that is how, according to the Standard Model, we now understand forces. The question is mass a force in the traditional way? And physicists say that it is. Now this might seem weird to you because mass just seems like a thing. It's a thing that you have. You have molecules and atoms, and they have mass. But some things don't have mass. A photon doesn't have mass, but it's very similar to an electron on an elementary level. So why does an electron have mass and a photon not have mass? And so physicists have sort of agreed upon the idea that it's the Higgs field that gives particles mass, and some particles interact with it and others do not. But instead of electromagnetism, which radiates from a point, an electric charge, mass doesn't come from a point source. My mass would be the same, we think, anywhere I am in the universe. So the idea is that the Higgs field, which is the field that gives things mass, exists throughout the entire universe. The other way of saying this is that Higgs force carriers, the virtual particles, the Higgs boson, exist at an even density throughout the entire universe. Particles without mass, like photons, don't interact with the Higgs force carriers, and so they don't have mass. And then there are other particles, like the electron, which interact weakly with the Higgs and thus are light. And then the top quark, which is the heaviest particle that we know of, interacts very, very significantly with the Higgs field, and so it has lots of mass. So that is the idea, and I hope that you get it. If you ask me why any of these things are this way, I can't get much deeper without I have no idea. But it's all just ideas in people's heads and numbers in computers until we can actually coax the Higgs particle into existence and say, there it is, it exists. We know why things have mass. Scientists have a very good idea of what the Higgs boson should look like. They're basically now just trying to find the energy level necessary to give it its mass. And so they're doing that right now at CERN. It takes a lot of energy, a lot of time, and a lot of data, which is why we still aren't sure, but hopefully by the end of 2012 we will know for certain. And until then, we're just waiting. And of course, Here at SciShow, we will keep you informed. If you have questions, we will do our damnedest to answer them in the comments. If you have suggestions for other things we should be covering here on SciShow, please tell us, because we love your ideas. And we will also be on Facebook and Twitter if you would like to get in touch with us there. Goodbye.